Hello there, Mr. Sutton here, bringing you the Algebra 2 4-7 lesson on transformations of polynomial functions. In this one, we will be graphing transformations of polynomials and also writing functions to represent transformations. So we're going to start it off with a couple graphing problems in which we're going to transform some polynomials. Our process for doing this is going to be very similar to what we did with linear functions and quadratics. Namely, we're going to describe the transformation. Then we're going to come up with a parent function table for the original function, x cubed in this case. And then we're just going to apply the rules of transformations to modify the x and the y values and use those new rules to write some new points, which we will then graph. So going through it a couple steps at a time here. First off, what is the transformation represented if we're adding 5 inside and adding 2 outside? Well, adding and subtracting is a translation. It's a shift. And stuff that happens inside, remember, is opposite of what you expect. Stuff that happens outside is exactly what you expect. Inside changes are horizontal. Outside changes are vertical. So adding 5 inside means we're actually shifting this 5 to the left. Adding 2 outside means we're shifting this 2 units up. So for the parent function, we're going to be making a parent table, and we're going to use the x values from -2 to 2. We don't really want to use larger x values because these exponents on polynomials are going to make this number go up pretty quickly. So here's my table with x values of -2 through 2, and we're doing this for f of x equals x cubed. So I'm just going to plug each of these x values into x cubed. So this is going to be -8, -1, 0. And you could use the calculator to do these if you needed to. Next we have 1 cubed is 1, and 2 to the 3rd power is 8. All right, now for our rules to modify the function according to the g of x rules here. If I'm going left 5, then I need to do x minus 5, subtract 5 from all the x values. If I'm doing up 2, then I need to do y plus 2. So let me do the x values first. Subtracting 5 from each of these. -2 minus 5 is -7. -1 becomes -6. 0 becomes -5. 1 becomes -4. And 2 minus 5 is going to be -3. Now we're just going to add 2 to all the y values they gave us. So that's going to be -8 plus 2, giving us -6. And then -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3, and 8 plus 2 is 10. Now I'll just create an x and a y axis that has enough room horizontally to go from -3 to -7, and enough room vertically to go from -6 to +10. So something like this, where we're going by 2's on the y-axis, and maybe just shift it left a little bit on the grid toward the left on the x-axis. So mapping these out one at a time, we have -7, -6. So left 7, down 6, right there. And then -6, 1 is going to be right about here. -5, 2 is right there. And -4, 3 is up here. And then finally, -3, 10 is all the way up here. And then I'm just going to graph this. Now, I have a little bit of background knowledge on what polynomials look like. We know that as you go to the far left and the far right, they go forever in whichever direction you were going, up or down. So this is going to look something like this. There we go. Here's another graphing example for us to do. This one has a different parent function, x to the 4th. So the parent table is going to look a little bit different. Pause the video and see if you can use the rules of transformations to make a new table and graph this one out. All right, so what's going on actually in terms of our transformations? Well, this negative here on the outside of the function is giving us a vertical reflection. Since it's outside, it's vertical. And this 1/4 is outside, so that's also a vertical change. It's since it's less than 1, that's a vertical shrink. So we have a vertical reflection and shrink. The parent table for x to the 4th, again, we're going to start with -2 through 2 for the x values. And I'm just going to plug all those into the 4th power now. -2 to the 4th is 16. -1 to the 4th is 1. 0 is still 0. 1 is still 1. So those are some nice, easy points to use every time. And then 2 to the 4th is 16. In terms of my rules, Since this is all vertical transformations, I don't have to do anything to the x values. So when I rewrite my g function with the table here, I'm just going to leave x the way it is. Now for the y's, I have to multiply those by a negative 1/4. Whatever it looks like is happening outside is actually happening the way it looks to this function vertically. So I'm going to write negative 1/4 y. That'll shrink all the y values and also flip them. So for the x's, I've still got negative 2, negative 1, 0, 1, and 2. For the y values now, I have negative 1/4 times all of these. 16 times negative 1/4 is going to be negative 4. It's like dividing by negative 4. And then 1 becomes negative 1/4, 0 becomes 0, 1 is still negative 1/4, and 16 is still negative 4. So I'm going to need a graph that goes from negative 2 to 2 horizontally, which isn't too hard to do. And then vertically, we can be a little bit more zoomed in if we wanted to go from 0 to negative 4. There's actually no positive values represented on this one. So I'm going to do most of my action below the x-axis here. We have negative 2, negative 4 right there. Negative 1, negative 1/4 is about right there, kind of close quarters there. And then 0, 0, the origin. 1, negative 1/4, and then 2, comma, negative 4. And then since this is an even polynomial, that means we are starting and ending in the same direction. Since it's negative, we're ending low and starting low. So we're going kind of like upside down parabola style. So we're going to segue into writing rules for transformations. So we have this f of x function here. It's x cubed plus x squared plus 1. And g is basically just f of negative x. We just want you to write a rule for g. Pause the video and see if you can piece this one together. All right, so all we actually have to do here is plug in negative x for all of the x's. So we have negative x cubed, negative x squared plus 1. Negative x cubed is going to be just negative x cubed without the parentheses. Negative x quantity squared, that's actually going to be positive x squared, negative times a negative. And then that 1 is still over there. And that's it for this one. Nothing else to do. For our next problem, we're going to do one of these where we give you a function and give you some transformations described in words and then have you actually write a function for that transformation. So pause the video and see what you can make out of this one. All right, so what's going on here? We have a vertical stretch by a factor of 2 followed by translation 3 units up. So we're going to take these one transformation at a time. I'm going to start by making a g function to do this vertical stretch by 2. So g is going to be 2 times the f function. So 2 times x to the 4th minus 2x squared. Distributing that, I have 2x to the 4th minus 4x squared. So I'm calling this the g function. Now I also need to do a translation 3 units up. So I'm going to take the g function and I'm going to transform it into what I'm going to call the h function, which is just going to be g of x plus 3. Well, here's all of g of x. It's just 2x to the 4th minus 4x squared. So I'm just going to stick that right here where the g of x is and put a plus 3 on the end. So there's the g of x. There's my plus 3. And that's it for this one. That is also it for the lesson. If you are doing the non-honors Algebra 2 CP version of this course, you can end the lesson now and go tackle that homework assignment. If you're doing the honors, then we are continuing on to do one more problem. For this problem, we have this v of x function below, 1/3 x cubed minus x squared, which we're told represents the volume in cubic feet of this pyramid. And we have this other function, w of x equals v of 3x, giving us the volume still in cubic feet of the pyramid when x is measured in yards. Now I guess this makes sense because there's 3 feet in a yard, so if you're suddenly changing your numbers into yards instead of feet, without adjusting the numbers themselves, they represent 3 times as much distance. What they want us to do is write a rule for w and then find and interpret w of 10. So pause the video and see if you can figure out all of this stuff, including w of 10. All right, so we just have to do v of 3x. So replacing x with 3x in the formula, pretty straightforward kind of process. And then we'll just simplify this a little bit. So we've got 3x cubed. That's going to be 27x cubed, but we need a third of that, so that's actually going to be 9x cubed. And minus, this is going to be 9x squared. So now w of 10, that's just plugging 10 in for x in this new formula that we made here. And let's see here. This is going to be 1,000 times 9 is 9,000 minus 900. We don't really need a calculator. That's just 8,100. Now again, this is in cubic feet. So that means that when x is 10 yards, that's what we're plugging in. This is yards that this function takes in. Our volume is 8,100 cubic feet. So that's it for this lesson. Hopefully it was transformative for you. Hopefully nothing was lost in translation, although upon reflection that might be a stretch. Until next time, Mr. Sutton signing off.